scalar multiplication. Yay! The set U. Got it? Okay, so our linear algebra question for today is to determine if the set U of all 2x2 matrices of the form A, B, 0, D is closed under scalar multiplication. So our set U, another way of writing this set U in set notation would be the elements in our set U are matrices that have the form A, B, 0, D, where A, B, and D are just real numbers. Okay, so this is another way of thinking about our set U. It's just the set of all 2x2 matrices that have a 0 in the third entry. And all the other entries can just be any number, it doesn't matter. Okay, so what we're trying to do is show if or determine if this set is closed under scalar multiplication. So what does this mean, closed under scalar multiplication? So if a set is closed under scalar multiplication, that means if you have some element in your set, so if you have some V that's in U, if we're closed under scalar multiplication, then we must have that some scalar times V. So this new element, so K times V, where K is just any constant, is also in our set U. So, and then K is just any arbitrary constant. So what this is saying is if I have some element in my set, in this case, the elements in my set are 2x2 matrices of this form. If I multiply by some scalar K, by any scalar, so if I multiply by a constant, does that necessarily guarantee that this new element, K times V, is still in the set U that we're talking about? So what we're going to do, how we're going to figure out if we're closed under scalar multiplication, is just assume that we have some element V in our set U, then look at the vector K times V and ask, is this in our set U for any arbitrary constant K or scalar K? So if we start by letting V be some element in U, and remember what U is defined to be the set of all 2x2 matrices of this form. So by definition, if we have a vector in our set U, it's got to be of this form. So I'm just going to write V has to equal A, B, 0, D for some constants A, B, D, right? So now we want to say let K be some arbitrary constant. So this is any real number. So 10, -20, a million. Is this new element K times V guaranteed to be in our set U? So we can just look at what K times V is. So K times V is K times the 2x2 matrix A, B, 0, D, right? And so if I remember the rule for scalar multiplication of matrices, I can put this scalar K, multiply it into each entry of my matrix. So this is actually just the same thing as K times A, KB 0, because K times 0 is 0, and then KD. Okay, so here's our new element K times V. We want to ask, is KV in U? So if it is in U, then we know we're closed under scalar multiplication. If it's not necessarily in U, then we're not going to be closed under scalar multiplication. So if we think about what it means to be in U, just from the definition of U up here, what it means to be in U is that we're a 2x2 matrix and we have a 0 in the third entry. All of the other entries, doesn't matter what they are, right? So if we think about, is this matrix, this 2x2 matrix, is this going to be in U? And because when we multiplied this scalar K, K times 0 was just 0, right? So it doesn't matter what K is, you're always still going to have a 0 in your third entry, right? So actually this set U is closed under scalar multiplication because no matter what constant we multiply any element of our set U, we're going to end up with a new element that's still in U because we still have the necessary condition to be in U, which is just that the third element of our matrix is 0, right? So since, I guess you could write since k times A, k times B, k times D are all just real numbers, right? And that was only conditioned on the rest of our entries where that was just that they're real numbers or they're constants. Since we met that condition, and also since we have a 0, right, in our third entry, we are closed. The set U is closed under scalar multiplication. We did it.